this lesson is about the Poisson distribution and Poisson process. So experiments yielding numerical values of a random variable x, the number of outcomes occurring during a given time interval or in a specified region are called Poisson experiments. So if we look at a few examples, we can have the number of customer service calls received per hour, so it is within a time interval or region. Number of days that school was closed due to snow per winter, so again, enclosed within a time interval. A number of baseball games postponed due to rain per season. So a Poisson experiment is derived from the Poisson process, and the process has the following properties. Okay, the properties, and perhaps the most important one is the first one, is the number of outcomes occurring in one time interval or specified region of space is independent, and I'm going to underline that, is independent of the number that occur in any other disjoint time interval or region. In this sense, we say that the Poisson process has no memory, so we say it's memoryless, no memory. So number two, the probability that a single outcome occurs during a short interval or small region is proportional to the length of time or size of the region. It's not dependent on what happens outside of that interval. And then number three, the probability that more than one outcome will occur in such a short time interval or fall in such a small region is negligible. The mean number of outcomes is computed from the equation mu, which is mean, is equal to lambda t, where t is the specified time, distance, area, or volume. And we'll see some examples where we could demonstrate what that looks like. Since the probabilities depend on lambda, the rate of occurrence of outcomes, so lambda is equal to rate of occurrence, so per hour, per day, per season. We shall denote this is the probability of x lambda t the probability distribution of the Poisson random variable x, representing the number of outcomes occurring in a given time interval or a specified region denoted by t, is, so we have the probability x lambda t, and this is equal to e to the minus lambda t times lambda t to the x divided by x factorial, and this is for x is equal to greater than equal to 0 or greater. Where lambda is the average number of outcomes per unit of time, distance, area, or volume. So E equals the 2.71828 standard value for E. And we are going to use table 8.2, and I'm going to go through that Poisson process on the next video so that you can see how to use the table, and then we'll work some problems, and you could use them computing the distribution formula, but we'll show you how to use the table. But one other side note, the mean and variance are both lambda t.